Today's lesson is 2-6, Apply Proportional Reasoning to Problem Solving. You will be working in your workbooks on pages 126 to 128. At the top of page 126, you will see example number 1. It says the ratio of collectible cards Deshawn owns to cards that Stephanie owns is 5-2. That's going to be important for us. And Stephanie has 36 cards. How will the ratio of Deshawn's cards to Stephanie's cards change if they both sell half of their cards? All right, so what you're seeing is 1, 2, 3, 4, 5 for Deshawn and 1, 2 for Stephanie. That is our ratio of 5-2. We know Stephanie is going to have 36, and we know they're both going to sell half of their cards. All right, so let's look at some options here for solving this. And you know your book really likes these bar diagrams. So we've got 1, 2, 3, 4, 5 parts for Deshawn and 2 parts for Stephanie. That's where this ratio comes into play. The other thing we know is that these 2 parts for Stephanie make 36 cards total. So I should be able to figure out that each part here for Stephanie, her 36 cards divided into those 2 blue boxes, gave me the 18 that you're seeing right here. There's 18 in this blue box and 18 in this blue box. From there, I know each box is going to be 18, so Deshawn's boxes are also 18. 18, 18, 18, 18, 18. So if I add up all of Deshawn's, 18 5 times is 90. So that's where they're coming up with this proportion. The 5/2 came there, and the 90/36 came from here. So let's back that up one more time. We knew we had 2 boxes, blue boxes for Stephanie, and we had 5 orange boxes for Deshawn because that was our ratio. We knew Stephanie's 2 blue boxes together made 36. So each one, if I divided her 2 blue boxes into 36, each one is 18. So all the boxes equal 18. If you count up Deshawn's 5 boxes at 18 each gave us 90. So that is where they are coming up with he owns 90 cards. Now that only takes us to how many cards Deshawn has. Then, remember, they're going to sell half of their cards. And there's a couple of ways of doing this. We can use the exact same picture that we had to the left, 2 blue boxes and 5 orange boxes. But if they're going to sell half of them, instead of them having an 18 in each of them, they could have a 9 in each of them because that would be half. So option number 1 is just to cut all of your boxes in half. Option number 2, just take your 90 and divide by 2. Take your 36 and divide by 2. So option number 2 is just to divide by 2. Regardless of how you do it, at the end, Deshawn is going to have 45 cards. Oh, let me change that. Deshawn is going to have 45 cards. And Stephanie's going to have 18. So that's where they're coming up with this ratio. If you were to put that into my calculator and hit simp, enter, until your arrow goes away, you would get 2.5. To convert that back into an improper fraction, you'd hit second, and the mixed number key. That's a lot of calculator strokes. We will practice those, I promise. Okay, so let's go a step further. This is the try it at the bottom of page 126. So remember, last time we saw Deshawn and Stephanie, they had sold half of their cards, but then, oh gosh, they got sad. So they ended up buying 9 new cards each. And we want to know the ratio of the number of cards Deshawn has to the number Stephanie has. So it's always best to start off, let's just think about our facts. So we've got Deshawn, and we've got Stephanie. And I'm just going to organize my data a little bit. And remember, we just found out after they sold their cards, Deshawn had 45 left and Stephanie had 18 left. If they each buy 9 more cards, how many cards will Deshawn have and how many cards will Stephanie have? And I want you to write that ratio in simplest form. So stop me, do that, and then come back for checking. All right, 45 plus 9 new cards gives Deshawn 54 cards. 18 cards plus 9 new ones gives Stephanie 27. So our ratio is 54 to 27. I can write a ratio like a fraction. If you hit Simp Enter, you are going to end up with, let me do it really quick. You're going to end up with 2. There's an invisible number 1 under here. This is your ratio in simplest form. If you got it right, give yourself a star. And if you did not get it right, would you copy off of this slide before moving on? All right, we have made it to the top of page 127. This is example number 2. It says Martin is 6 years old when his sister Cassandra is 3 years old. So we've got our data right here in a table. How old will Martin be when Cassandra is 6? So we're just going to keep counting. I'm going to change Martin maybe to a red color. 6, 7, 8, 9, and Cassandra will make her green. 3, 4, 5, 6. I can stop that table because I want to know when Cassandra is 6 years old, and I've got that right here. How old will Martin be? Well, Martin's going to be 9. But I want you to look at this carefully. You are not, when you divide, getting a proportion. You will not get the same number every time. And the reason you are not is because they are adding instead of multiplying or dividing. All right, we're on example number 3, still on page 127. All right, a video streaming service charged Brian $143.84 for a full year of access. Brian thinks he was not charged the correct amount. What should Brian say when he calls customer service? All right, and here is his ad. That's got some important information. It says he's going to pay $8.99 a month. So on this one, for step 1, they went ahead and they wrote their equation. Remember, your constant of proportionality is just your multiplier. So the cost is going to be $8.99. Let me change that to a pen instead. $8.99 times however many months will give you your cost. Well, there's 12 months in a year. So it should have cost him $107.88, but oh my gosh, look what they charged him. So if I was Brian, I'd be like, hey people, you charged me $143.84 when I only should have been charged this month. You need to give me back $35.96. Now they had another option for those of you with really good number sense. And they figured out on option 2 that actually Brian was charged for 16 months of service. If you took $8.99 times 16 months, that's what they charged him. But that was 4 months too many. And so if this was the option, he would say, hey, give me back my 4 months. A florist makes bouquets that includes 50 white flowers and 7 red flowers. If the florist orders 1,050 white flowers and 140 red flowers, there will be leftover flowers. How can the florist adjust the order so that there are no leftover flowers? All right, can I make a suggestion here? Oh, let me change that to a pen, not a highlighter. I think skip counting in a table might just be the thing we need to do. So we are going to have the white flowers, and we're going to have the red flowers. And let's just organize our data for a minute. We have 50 white for every 7 red. If we add another 50, we're up to 100. If we add another 7, we're up to 14. Now you're going to skip count until you end up with 1,050 white flowers. Now I wouldn't do that. I would figure out how many of these 50s I have to get to 1,050, and that's how many of these 7s I have to do. All right, so I'm going to have you stop me for a second. I want you to go ahead and figure out how is the order needing to be adjusted so there are no leftover flowers. Okay, so as I said, I was not interested in skip counting by 50s to get all the way up to 1,050. So I used my number sense and I figured out that would be 21 skip countings or 21 bouquets. This is how I did it. Here's my secret. I took 10,050 divided into groups of 50, and that gave me 21 bouquets. So if I have 21 white flower bouquets, I also need red flowers in the bouquets. So if I skip counted by 7, 21 times, I skip counted by 7, 21 times, I would get to 147 red. So if I did that, I would suggest to the florist that the florist, needs 1,050 white, but only 147 red to have no leftover flowers. Now you could have done this using the red flowers instead, and you would have gotten a different adjustment, and that one is fine as well. All right, please turn to page 128. It is time for you to do your do you know. You are on question number 4. Can I make a suggestion? I might do a skip counting table, comparing my flour to my milk to help me with A. And then on B, I think I can probably use a proportion. So I want you to go ahead and stop me right now and then come back when you're ready with your answer. All right, I'm going to go ahead and put in my data. 15 ounces of flour for every 8 ounces of milk. If I double the recipe, I add another 15 and another 8. For the next one, I add another 15 and another 8, and I could keep going if I wanted to. But it just is asking is this proportional? Well, we know how to do that. We're going to divide. Whoops, let me use a pen instead of a highlighter. We're going to divide bottom up. Divide bottom up. Divide bottom up. And if you do that, you are going to get 0.53 every single time. If you get the same answer every single time, then yes, it means it is proportional. So the answer is yes. Each time the COP equaled 0.53. All right, part B. If I have the ratio 15 ounces of flour, I'm going to use my words, and 8 ounces of milk in the recipe, and I want 15 ounces of milk, that goes on the bottom, I should be able to cross multiply and divide, and your answer is going to be 28.125, or if you're using a fancy calculator, 28 1/8 ounces. If you got this right, you're going to star yourself, and if you did not get it right, please copy from me. All right, last problem. This is also on page 128. It says a packing company makes a popular fruit cocktail. To ensure a good mixture of fruit, there are 3 cherry halves for every 8 white grapes. That's hard to say. An inspector notices that one jar has 12 cherry halves and 20 white grapes. What can be done to fix the error? I want you to work on this and come back when you have an answer. All right, I really like a skip counting table for this. Oh gosh, I keep doing a highlighter instead of a pen. Let me change it. We have the cherry halves. We have the grape halves. I guess they're white grapes. For every 3, we have 8. So I'm just going to start skip counting. 3, 6, 9, 12, 15. I don't know how many I need. I'll go up to 18. 8, 16, 24, 32, 40, 48. Okay, I'm not sure if that's enough or not. Let's figure it out. So it says an inspector notices that one jar has 12 cherry halves and 20 grapes. 12 cherry halves should have 32 grapes. So it looks like to fix the error, there needs to be 12 more grapes added. To the fruit mixture. If you got that right, I want you to go ahead and give yourself a star. And if you did not, would you please fix it before you leave the screen?